Well, this chapter's about energy, which is always important in physics, but this first video is actually going to be a pretty short video. There's an enigmatic statement in the specification which reads as follows: derive and used EK equals p squared over 2m for the kinetic energy of a non-relativistic particle. Well, this non-relativistic particle is the enigmatic bit. But for now, that's something that's dealt with when we get to particle physics. So for now, all you have to realise or think about for that is that it's just a normal particle, nothing weird or strange about it, just an everyday particle. But the other curious thing here is that they ask you to be able to derive an equation, which is quite unusual in the specification, very unusual. So, well, let's just see how to do it, because questions do kind of, multiple choice questions especially, just kind of refer to it, the derivation. Well, we know that EK is the kinetic energy. P, of course, is the momentum. That's the starting point, and I recommend just following these steps. So momentum is mv, square the momentum, and you get that p squared is m squared v squared, and then divide by 2m. So you get p squared over 2m equals m squared v squared over 2m. But then look what happens to the right hand side. One of the m's cancels out, and you get mv squared over 2, which is a half mv squared, of course, which is kinetic energy, which is what EK is. So that is the derivation. So there's a couple of types of question that crop up using that formula. The first type is generally associated with the derivation, and the first couple after this video, the first couple in the challenge, along those lines. And they're pretty straightforward, and hopefully you'll find those just fine. The second type are a bit trickier, and maybe we ought to just have a little bit of a deeper look. So here's an example. A particle has momentum P and kinetic energy E. If the kinetic energy reduces to E over 2, what is the new momentum? Well, the first thing to realise is that because the particle is the same before and after, then its mass must be the same. It's the same particle. And so it has a momentum changing, so it must be the velocity that changes the momentum and the kinetic energy. So here's the technique, and it's a technique which I have used before in other videos and is really useful for any type of question where they do this in any topic, where they say something changes and what's the effect on something else. So the first step is to find the equation. Well, obviously we know exactly what that is today because it's the one we've been looking at. So it's EK equals p squared over 2m. Step 2 is to see, well, what is the thing we want to find? We want to find the new momentum. So because it's momentum we're looking for the effect on, we rearrange the equation in terms of momentum. So hopefully it's clear that if I rearrange this, I'll get momentum is root 2MEK. Third step is to rewrite the equation in the form using the symbols used in the question. Well, they're using P, which is the same as in the actual equation, but they're saying kinetic energy is E. Now we've got EK, so there's not much difference really, but it's still worth rewriting with the actual symbols. Sometimes they might have X and Y, and then it can get a bit confusing. So let's rewrite. So we're going to say, okay, well, using the symbols of the question, the momentum, but just applying our basic equation, momentum is 2me. We know that must be true because that's the relationship between momentum and energy, kinetic energy. Now the next step is to say, well, okay, let's make the change to discover the new value of the quantity. So the new momentum, and I'm going to call it P dash, is going to be root 2m times the new energy, which is E over 2. And then all we've got to do now is write that in terms of the old momentum P. Well, it's tempting to cancel the 2's, don't do it because we want to find our solution in terms of the old P. But hopefully you can see that I could write that as 1 over root 2 multiplied by root 2me. Yeah, so you might want to pause and just think about that for a second. And then If we keep going, well, I can actually write that as 1 over root 2p, because that is just p, the old momentum. Or, for that matter, I can just write even more simply p over root 2, which would probably be how it cropped up in the multiple choice answers. So good, hope that makes sense. There's a couple of those coming up too in the challenge, so good luck with those.